Alright, second subtopic, which is on scalars and vectors. So in this subtopic, you have to be able to define what is scalar and vector quantities, resolve the vector into two perpendicular components such as x and y axis, and lastly determine the resultant of the vectors lah. So in our syllabus, it only limits to 3 vectors only. Okay, so scalar quantities, it is defined as a quantity that only have magnitude. Okay, for example, we have mass, distance, speed, work, pressure, current, and temperature. So all of this doesn't tell us about the direction. So that is why it is called scalar quantities. For vector quantities pula, it has both magnitude and direction. Okay, so it has both magnitude and direction. So that includes velocity, force, momentum, impulse, and torque, electric field, and magnetic field. Okay, so all of that are vector quantities because they tell us where they are going. So where they are heading, where is the direction. Okay, so that is what we call as vector quantities. Now you have to be able to resolve a vector into two perpendicular components. Okay, so this part you will be using it across all chapters, so you have to be able to understand this basic part. Okay, so if you have problem understanding what I'm trying to do here, please let me know in the class lah. Okay, I'll help you as much as I can lah. Right, so a vector may be expressed in terms of its components, which is x-axis and y-axis. As it can be expressed into its components, this resultant vector can also be determined lah. So below is the strategy on how we are gonna solve this problem. Okay, so for example, now we have this force A here. Okay, so we have this force A here. Since this is a vector, we can resolve it into its x component, and y component. Okay, let me use another color now. So we can resolve it into fx also as fy. Okay, so this force A here, we can then calculate the magnitude of the resultant vector, as well as we can calculate the x-axis component and y-axis component, and then we can total it up and we can determine the direction lah, which is using this equation here. Okay, I'll explain how we are going to use this in this example here. Okay, so first you need to understand that we are going to use trigonometry lah. So if you are going to calculate the angle theta here, you can either use cosine theta ataupun sine theta. And then this angle theta, which is the direction of the resultant vector, can be calculated using this equation here lah. And always remember that theta is measured relative to the x-axis. Okay, it's not going to be from the y-axis here. No, it's going to be from the x-axis. It can either be on the left, which is on the negative x-axis, ataupun on this positive x-axis. Okay, all right, let's go on to example 3. So this is a displacement vector. So displacement vectors, I'll label it as S lah, S. Okay, so they have a magnitude of 5 meter, 5 meter, and 4 meter. We have to find the resultant of these 3 vectors. Okay, so remember, displacement displacement is a vector, so we have to resolve it into its own x and y components lah. Okay, so first of all, I'm gonna do for for displacement A, I'm gonna do this color. So we are gonna resolve it into its own x and y component. Okay, I'm just gonna draw it so that you understand what I'm trying to do. Okay, so this is SA untuk x component. This is displacement for A at the y component. This is for B y component. This is for B at the x component. Okay, so for displacement C, there is no x and y component because there is no x component because it lies on the y axis. Okay, right, so I'm now gonna draw the table. If you do not want to draw the table, there's no problem. You just have to avoid doing silly mistakes. So there's three displacement vectors, so A, B, and C. So this is the total. So this is your displacement, this is your x component, this is your y component. Okay, so this is for component A, sorry, not component, for displacement A, displacement B, and displacement C, and this is your total. Okay, so for x component of displacement A, we are gonna resolve it using cosine theta. So why are we using cosine theta is because the angle, before that I'm gonna label this as theta A, this is theta B. Okay, always label your information that you have lah. For example, SA is equal to 5 meter, it's given already. Theta A is equal to 20 degree. Then we have displacement B, which is equal to 5 meter as well, and theta B is equal to 60 degree, and lastly we have displacement C, which is equal to 4 meter. Okay, so always try to extract the information from the questions ataupun the figures so that you avoid making silly mistakes lah. Alright, so for component x component of displacement A, sorry, we are going to use cosine theta because this angle is lying on the x-axis. Okay, so if the angle lies on this x-axis, we are going to use cos theta. Tapi kalau this 20 degree now ni is on this y-axis, and then we are trying to resolve it in this x-axis, we are going to use sine theta. Okay, hopefully kamu faham lah yang apa yang saya trying to cakap now. Okay, so and then this is going to the left. Okay, so anything that goes to the left will be negative, and anything that's going down will be negative as well. So if it is going to the right and going up, it is gonna be positive. Okay, so always remember that part. So let's resolve the x component. So this is going to the left, so it's gonna be negative as displacement A cos theta A. Okay, and then for y pula, the angle lies on the x-axis, so we are gonna use sine theta A. Okay, and then for displacement B pula, it's gonna be as B cos theta B, and this one is gonna be sine theta B. Okay, so for displacement C pula, the x component is 0 because it lies on the y-axis. So this is going to be negative displacement C because it is pointing down. Okay, so if you want to use, tiba-tiba kamu pun mau guna lah semua cosine lah cos, tidak mau sudah sine. What you're gonna do is you have to find lah apa angle di sini untuk y-axis ni. So angle ni 90 minus 20 is equal to 70. Okay, so this is gonna be 70 degree lah. So contohnya kamu taruhlah sini cos 70 degree. Baru dia akan sama dengan sin theta A. Okay, tapi janganlah buat begitu, kamu buat saja cara Miss buat di sini. Okay? Okay, now you are gonna total it up, add all of this together. So you will get, saya lupa, so saya delete. I erased it just now. Oh my god. Okay. But it's okay. So this is gonna be total at the x component. So this is gonna be negative 5 cos 20 degree plus dengan 5 cos 60 degree. So calculate that using your calculator. I have to do mine as well because I do not have the answer. So you will get negative 2.198 displacement, so meter. Okay, so the total for the y component is gonna be 5 sine 20 degree plus 5 sine 60 degree minus 4, which is the SC lah. So this is gonna be equal to 5 sine 20 plus 5 sine 60 minus 4. So you will get 2.04 meter. Okay, so you can either take three significant figures, which is 1, 2, 3 significant figures ataupun 3 decimal places lah. Okay, so if it's me, I would always take 3 decimal point lah. But for this one, it is 2.040 kan. Jadi ambil je lah 2.04. Okay, so after that, we are gonna calculate the resultant vector. So the resultant vector is gonna be equal to sorry, I forgot to add s here, displacement. So it's gonna be sx square plus sy square. So this one you will get again, let me calculate it first. Plus with 2.04, you will get 2.998, which is equal to 3 meter lah. Okay, sekarang dia minta a resultant of the 3 vectors. So remember, it is a vector, so you also have to calculate the direction lah, the angle theta. So this is shift tangent. Y is berapa y tadi? 2.04 divided by 2.198. So that is gonna be shift tangent 2.04 divided by 2.198. So you will get 42.86 degree. Okay, so the displacement displacement x is negative, so it is going to the left, and y is going up because it is positive, so the angle theta is from the negative x-axis. Okay, so this is gonna be from the negative x-axis. All right, okay, so that is at the end of our chapter 1.